Good morning, students. Today we talked about our first data structure topic, that is introduction to solving in data structure. Okay, means why data structure is required and what exactly problems are there and how we are going to solve it. Okay, so before that, first is what is problem solving. So problem solving is the application of ideas, skills, or factual information to achieve the solution to a problem or to reach a desired outcome. Okay, so what exactly problem solving is? It is a one type of ideas or skill or one kind of method in which we are going to solve the problem. Okay, so how we are going to solve that problem? Before that, we should know what kind of problems are there. Okay, this is the types of problems. First one, well-defined problem. Okay, so there are four type of problem: well-defined problem, poorly defined problem, routine problem, and non-routine problem. Okay, so what exactly well-defined problem is? One that has a clear goal or solution and problem-solving strategy are easily developed. Means what? Well-defined problems. So giving you an example for that. For example, if I am telling you that you have to implement program and you have to implement the addition operation using C++ language and take two variables for the scanning the input and one variable for storing the result. Means that in this problem statement you have clear cut given the problem statement. So this is concept of well defined. Every statement or every concept is clearly defined. I'm taking second example, that is if I'm saying that if you have to write the program or develop the program in Python language for addition of two numbers like that, means the clear cut problem definition is given is called as well defined problem. Second one is poorly defined problem. So poorly defined problem is the exact opposite of well defined problem. It's one that it is unclear, abstract or confusing and that does not have a clear problem solving strategy. Okay, so in this process, we are going to see what exactly poorly defined problem is. Poorly defined problem means that there is some unclear, confusing problem statement. If I am saying you have to implement the program for addition, you take two variables. That's it. Means problem definition is not clear. Which kind of language we are using and how exactly we are dealing with, it's not clear. So this is a concept of poorly defined problem. Okay. And the routine problem. Third one is routine problem is one that is a typical and has a simple solution. For example, routine problem like let's say if always let's say in timetable my lecture at 9:50 in offline details. Okay, I'm talking about when you have attended lecture on first year. Okay. Some of the time lecture started from 9:30 and students enter into the lecture at 9:50. Always students came late. This is daily routine problem. Always student says that, Madam, we are the up-downers. We don't have bus facility till so that we are not reaching at the proper time. So these are the problems arising. Okay. So this problem is called as the daily routine problem. Means there are typical problems out there. Okay. If, every day the student says same happen the same problem. They always came late in lecture and always given the solution, simple solution. This is the one kind of problem. And next one is non-routine problem. Non-routine problem is more abstract or subjective and requires a strategy to solve. Non-routine problems means in daily routine problem, some obstacles are happen. For example, if I'm conducting a lecture and suddenly principal sir came in lecture and asking the questions to students. So this problem for me, that is a non-routine problem because principal sir is not coming every day in my lecture. So this is concept of non-routine problem. So there are four types of problems are there: well-defined, poorly defined problem, routine problem, and non-routine problem. Okay. So what kind of problem solving strategies are there? Okay. So what kind of problem solving strategies? The first strategy is the very well-known concept that is algorithm. Algorithm means what? How to solve. We have seen what is meant by problem solving. What are the different kind of problems? Now we are focusing on problem solving strategy. Okay, the first strategy you might try when you are solving a routine problem is called the algorithm. Algorithm is a concept that is we are always solving any kind of problem step by step. Okay, so our process for how to solve a problem or achieve a goal. Okay, this first is step by step execution and step by step process to solve that problem. And second one is what heuristic. What is the second problem strategy? Heuristic means that it is another solution that many people use to solve the problem. Heuristic means it is a shortcut solution to solve that problem. It's called heuristic. But the outcome of that problem solution is not long. Okay, because it is shortcut. Heuristic are general strategy used to make a quick. Okay, and the how to solve that problems we're going to see. Previously, we have seen what is meant by problem solving. These are the types of problems. How to solve that problem using problem solving strategies. Then how we are focusing on how to problem solving principal steps to solve that problem. Means problem solving some principles are there to solve that problem. So what are those points? So first of all, we have to identify the problem. Then second, understand the problem. Next, identify alternative ways to solve a problem. Select the way to solve a problem from the list of alternative solutions and evaluate the solution. This is the problem solving steps which are going to perform for solving that problem. Okay. So first one, identify the problems. Okay. What do you think about identify a problem? Means basically we have to find out first important step is that we have to identify a problem. So what kind of problems are there? We have to find because finding a problem is one kind of problem, isn't it? If I'm taking about the example of final year students for selecting the project topic, students are always in confused state. What exactly problems are there in previous system? So which kind of topic we are going to take for final year project? Student always in confusing state. So how we are going to solve that problem? Problem identification is very big concept. First, you should identify where exactly problem arises. Okay. First of all, we have to identify it. Second one, understand the problem. When you have identified the problem, you should understand how we are going to solve it. What are the major factors of that problem? This is understanding process. Next one, identify alternative ways to solve a problem. Yes, when you have understood all the concept of that problem, what kind of major factors are there, then you have to identify alternative ways to solve a problem. Okay, so how we are going to identify the alternative ways to solve the problem? So select beat a way to solve a problem from the list of alternative solutions. Yes. So when we are identify alternative ways to solve that problem, you have to select one solution from them because when you identifying understood the problem, then you have lots of alternative ways. You have to check कौन सा एप्लीके और कौन सा वेज उस पे सूट होगा जो प्रॉब्लम हमारा solve होने वाला है. So we have to select one and evaluate the solution. Finally, we got the solution of it. It's very important to solve the problem. These steps are very important when we are solving any kind of problem. So this is important. Fine. So we have seen previously that is what is the problem solving, then it is a particular or some skills, idea to achieve or to solve that problem. What kind of problems are there? These problems are very famous, that is well defined, poorly defined, routine problem, non-routine problem. Next one is these are the problems arises in daily routine. So next one, problem solving strategy. So what are the two basic problem solving strategies are algorithm and heuristic. Algorithm means step by step process. Heuristic means the shortcut process. Okay, to solve that problem. Okay. So we have to find out problem solving principles step to step. So what are those? So first of all, we have to identify problem, find out करना है where the problem is arises, understand the problem, then identify alternative ways to solve a problem, select a beat way to solve a problem from the list of alternative solutions, and evaluate the solution. Okay, so So this is related to problem concept. Okay, so we are talking about the algorithm because we are when we are solving the problem in technical way, we have to use the algorithm. Okay, so what is exactly algorithm? Everyone is clear. That is, it is a step-by-step process for execution. So, so what time? So, what are the major factors to analyze that algorithm? How we are going to evaluate it? That is the time complexity factor. Okay. Before that, we are going to focus on what is exactly algorithm is. Okay. So when we are talking about in technical way, algorithm is a concept. This concept for general way. Everywhere we have to use algorithm in terms of technical, non-technical, any kind of problems when you are solving, you have to follow this step. Okay. So in technical way, we are going to see an algorithm is a finite set of precise instructions for performing the computation or for solving the problem. It is a finite set of precise instructions. There is some fixing steps we are going to follow to solve that problem. Okay, fine. So what are the properties of algorithms are? The first one is input, second output, definiteness, correctness, fitness, finiteness, and effectiveness. So for the algorithm property, first of all, we have to give the some input from a specified set. So what kind of input you have, what you are going to process it, and what kind of output you want. Means always remember that any kind of algorithms we are developing, before that we have to give some input from a specified step, and when the processing it, we have produced one solution or the output in terms of any uh, factors. Okay. The next point is definiteness. It is for every step in the computation. Yes, every step in computation means every step we are going to perform. Okay. Correctness of output for every possible input. Yes. Our algorithm concept is that input, output, and the processing is that is definiteness, correctness. Correctness means that any kind of different kind of input our system should be always giving the correct. This is the correctness of that. When your algorithm is perfect, how we are going to check it, how we are going to testing it, when we are providing the input in terms of different way, and we are checking different inputs we are providing to our algorithm, then it will processing and will produce the output. Okay. Finiteness of the number of calculation steps, it's very important. आपसे कितने steps आप follow कर रहे हो और उसमें कितना time जा रहा है, ये देखो. When our algorithm is based defining depends upon finiteness means what number of calculation steps are very important in our algorithm. Okay, the next one is effectiveness of each calculation steps. And okay, so how we're going to perform it first of all. So algorithm, the major factor is that input, processing, and output. This is the major factor here. Okay, so how we are defining here our algorithm is best. We're going to tell us the algorithm is best depend upon algorithm analysis. Okay, so why we should analyze the algorithm? So there are two factors, that is computational time and memory space. So there are two major factors for analyzing the computer, that is time complexity and space complexity we are going to see. So time complexity means like CPU consumption, computational time, how much time required to solve or to execute that line or instruction in the memory, and the uh, space complexity means RAM we are using the memory space. Okay, so communication bandwidth consumption is very important. So the algorithmic analysis, the major factor, that is the running time of an algorithm, is the total number of operations executed is known as the algorithm complexity. Total number of operations we are executed is called as the algorithm complexity. So what exactly complexity is, we will see next. Okay. Before that, you should clear what is exactly algorithm, what are the properties of algorithm. Next one, next point is what exactly algorithm analysis we are doing. There is two factors. Computational time is time complexity, RAM consumption means space complexity, and what exactly algorithm complexity is. The running time of an algorithm is the total number of operations executed is known as the algorithm complexity. Okay, so we'll see it properly. Okay, so these are the two major factors algorithmic complexity. We have seen algorithm analysis in which again we are going to concentrate on algorithmic complexity, that is two factors, internal factors and external factors. In internal factor there are two parts, space complexity and time complexity. And external factors are processor quality and CPU speed. Okay, these external factors we are not concentrating on them because we are using or purchasing the external factors here. So here we are concentrating on internal factors, that is algorithmic complexity having two factors, space complexity and time complexity. Okay, so we are focusing on time complexity here. So basically what exactly time complexity is? So time complexity is of an algorithm. It gives how much time required to run that program, or how much time required by the program to run to a completion. Yes, how much time required to run that program step by step. Okay, this is the concept of time complexity. And time complexity of an algorithm is measured by its rate of growth related to the time function. So what are the three cases of time complexity are? Worst case, average case, and best case. Okay. So what is meant by worst case? What is meant by average case? What is meant by best case? Worst means that always thinking about it is an upper bound on running time of for any input of given cycle. If I am giving one particular example here, if I have given six elements. Okay, you are storing that six element in array. Likewise, I am storing 5, 4, 3, 2, 1. These five numbers I have given to you, and you have to arrange the 5, 4, 3, 2, 1 in ascending order. So the ascending, when we are arranging in ascending order, whole list or whole number of elements, if you are storing in array, so 5, 4, 3, 2, 1, whole list you need to sort it. Means how much time it requires for worst case time complexity. Means we have to compare each and every element. Dear student, here we are going to focus on what exactly worst case is. Using example will clear all these things. Okay. Worst case means whole list is unsorted. We need to sort each and every element. If I'm talking about 5, 4, 3, 2, 1, 5 is compared with 4, 4 compared with 3, 3 compared with 2, 2 compared with 1. Likewise, whole list we need to sort. This is the worst case analysis. Average case means some of the list is sorted, some of the number of elements are unsorted. Likewise, 5, 4, 3 is unsorted, 1, 2 is sorted. So half list is sorted, half list is unsorted. This is the concept of average case. And what about base case? Base case means what? All lists are sorted list. If I am giving the input is 1, 2, 3, 4, 5, and I am telling you that you have to sort all the elements in ascending order. But in this case, all the elements are in sorted order. So no need to sort, right? So this is the concept of best case. So this is the worst case, average case, best case. These are the 3 points. So later on, I will more focused on that example. Using that example, real time example, you have definitely clear all the concepts. I hope everyone is clear today's topic. That is what is meant by problem solving. Okay, what is meant by problem? Then type of problems. What is the problem solving strategy? Then problem solving. What are the different steps to solve the problems? We have seen the time complexity of that problem. Then what is algorithm exactly in technical way? Then what are the properties of algorithm? How to analyze that algorithm? There are two factors, time and space. Okay, what is algorithmic complexity? There are two factors, internal factors and external factors. In internal factors, space complexity and time complexity are there. And in time, we are focusing on time complexity. That is, time complexity means how much time required to execute that program. Okay, in which we have seen worst case, average case, best case. Okay, thank you.